Yes. Is my screen visible to everyone? दिख रहा है?
Yes, sir.
Someone please confirm.
Yes, sir. Yes, sir.
ठीक है, okay. So we will start now. So we will continue with the topic of Intz tank, and we will see the design of staging now. Okay. So
सर
till now,
साउंड थोड़ा
yes.
लैग हो रहा है.
Sorry.
साउंड थोड़ा लैग हो रहा है सर.
Probably network issue. Anyway, just try to keep up. Okay. Okay. So we have designed the Intz water tank container. In that we have designed the top dome, top ring beam. Then we have designed the cylindrical wall. Then the bottom ring beam. Then conical dome, bottom dome, and that's it. Okay. So these these components they basically gives you the container part. Now this container is basically supported on the bottom ring girder. The design also we have covered in the previous lecture, and this bottom ring girder is now supported by a staging system. So this staging is basically consisting of columns and bracings. Okay, so you can see on the left hand side there is a completed Intz water tank, and here you can see there are different number of columns, and if you count the number of columns, there are 8 number of columns which are supporting this Intz water tank. Okay, so today we will see the design of this staging, which consists of column as well as the bracing. Okay, so now have to take some data. We have to assume those data. So this was the problem statement which we have considered. That is, we have designed the Intz water tank for a capacity of 1000 meter cube. And as far as staging is concerned, the number of columns which are supporting the staging, which are supporting the container, is number of columns as 8. And the base of the water tank is 16 meter above the ground level. This is what we are assuming. And then we are assuming that the depth of the foundation, so every column will be given a foundation. So that foundation depth is 1 meter below the ground level, and at that particular level the SBC of the soil is taken as 250 kilonewton per meter square. In actual practice you have to find out the SBC using the setup, and then you have to design accordingly the foundation part. For design purpose, we are using M25 grade concrete and Fe415 grade steel. Okay. Again, we will be using IS3370 part 2 for the design purpose. And for this design purpose, the sigma CBC value as per IS3370 part 2, we have to take it as 8.5, and the sigma ST value as 130 Newton per mm square for Fe415 grade steel. And accordingly, since we are using this working stress method, so we have to find out the design constants. One is the modular ratio. So modular ratio can be calculated by a simple expression, 280 divided by 3 times sigma CBC, which comes out to be 10.98. Then the value of K is coming out to be 0.418, and value of J is 0.86, and value of Q, that is the lever arm constant, is 1.527. Okay, so these are the standard thing which we will be requiring for the design of columns and bracings. Okay, so now if you remember, in the previous class we have already designed the Intz tank, and using the basic equations we have calculated the various dimensions to accommodate the water of 1000 meter cube. Like the internal diameter, we have considered this as 12 meters. The radius of the dome was 10. The rise of the top dome was 2. The height of cylindrical wall was 8, and the height of conical dome was 2.5. It is making an angle of 45 degree, and correspondingly we have identified and we have calculated the innermost diameter, that is D0, that is the diameter of the bottom dome as 7.2, and the height as 1.44. Okay, so the same data we are continuing for the design, right? So now coming to the design part. So we are assuming the diameter of each column as 650 millimeters. Okay. So this is your 650 millimeters. Just a moment, please. Mhm. Just a moment, please. Yeah. So we are assuming the diameter as 650 mm and the length of the column as 16 meters. And what we are doing is we are assuming the bracings at a distance of every 4 meter. So this is, let us say, if this is your column. Okay. So we will be having one bracing over here, one bracing over here, one bracing over here, and here you have a foundation, and here you have a container like this. Okay, so this is nothing but 4 meter. Okay, so at every 4 meter we are assuming a bracing. The size of the bracing which we are assuming is 500 mm by 500 mm. Okay, now remember, while designing the container, we have calculated the total vertical load. Okay, so if you remember the design of the top girder, we have calculated two things: one is capital W and one is the small w. So the small w was basically the UDL which is in per meter. That is the total load which is coming on the container, on the girder. This was in kilonewton per meter. Okay, and the capital W was in the kilonewton. Okay, so if you refer your earlier notes, you will find the small w value was 704.65. Okay, so this was per meter, but if you calculate the total load, so it was coming out to be 15,900 and 38.8 kilonewton. Okay, do you remember this? याद है ये? Please cross check your notes and see whether you are getting these values or not. Is it fine?
Yes, sir.
Okay, so so this was the total load which was coming at this joint. Okay, so if you are calculating the load on each and every column, all you have to do is just take this value of capital W. So capital W is 15,938.8 divided by n. N is nothing but the number of columns. So this is a total, or I should say the actual load in the column. How much is this? कितना आ रहा है?
1992.35.
1992.35
5.
kilonewton. Okay, so this is the total load which is coming on the individual column. Okay, now as far as the self weight of the column is concerned, so all we have to do is calculate the value, volume. So this is pi by 4, so this is pi by 4. The diameter of the column which we have assumed is 0.65, that is 650 mm, which is over here. Okay, so this is going to give you cross section area multiplied by the length of the column is basically 16 meters, so this is going to give you a volume, and density is 25. How much is this? Yes, please.
132.73.
Okay, right. Then we have to calculate this self weight of the bracing. Okay, so now bracing is basically you can assume this as a circular beam, and these circular beams are there at three different locations as indicated over here. That's why we are going to multiply it by 3. So we are basically calculating the weight of single bracing and then multiplying it by 3. So this is cross section area. So if you see the cross section area of the beam, it is 0.5 meter by 0.5 meter. Okay, so this you can see over here. This is what we have assumed. And pi d0, so pi d0 is nothing but the perimeter of the structure. Okay, so where d0, so if you turn back, you can see the d0 value is nothing but 7.2 meters. Okay, so this d0 is nothing but 7.2 meters, and gamma c is nothing but 25. So can someone tell me what is the value self weight of the bracing?
424.
Point
115.
kilonewton. Okay, so now you have to calculate V1. So V1 is the total vertical load, which is the summation of this load, that is the load from the container, then the self weight of the column, and the self weight of the bracing. So can anybody tell me what is the V1 value, please?
Sir, 2549.19.
Point
19.
19 kilonewton. Okay, so 2549.19 kilonewton is the vertical load which is there on the column, and this load is only due to the vertical gravity loading. Okay, that is basically the self weight plus weight of the water. Okay, now since this is a elevated kind of a tank, it will be subjected to a wind pressure. Okay, so depending on the type of the city, you have to refer the IS code, and the value of wind pressure has to be taken from the IS code. So as far as this problem is concerned, I am assuming the wind pressure as 1.5 kilonewton per meter square. So this wind will be acting from any direction. So here on the right hand side figure you can see one direction is assumed. This is basically wind pressure of 1.5 kilonewton per meter square. Okay, since this is circular in shape, the reduction coefficient will come into picture, because if you see, if you have a curved surface like this, and if there is a uh, pressure which is acting like this, so as far as this part is concerned, this part is curved in nature, so your pressure will be reduced because of this curvature of the structure. Therefore whatever pressure you will be calculating, it has to be multiplied with zero point 0.7 if it is circular in shape. Okay, if your shape is rectangular shape, perfectly rectangular, then there should not be any reduction. So reduction coefficient will be 0, or rather it should be considered as the same pressure which you are calculating. Only in case of circular shapes, the pressure has to be reduced by 30%. Only the 75% 70% of the load will be acting. Okay, so this is as per the IS code. So let us calculate the wind pressure one by one. So the very first wind pressure which we are going to calculate over here is the pressure which is acting on the top dome and the container. Okay, so this container basically it is of this shape. Okay, we have a vertical wall, we have a vertical wall, and then we have the rest of the system. Okay, so what we are doing is we are assuming this as a shape which is triangular like this. Okay, so we are going for the exposed area which is shown in the shaded portion. Okay, so if you calculate the exposed area, so you have 8 into 12. So 8 is nothing but the height of the wall. Okay, and 12 is the diameter. So this is going to give you this much of area. Okay, so this is first area, plus 2 into 12 divided by 2. So where this is nothing but your 2. Okay, and this is nothing but your 12. So basically we are calculating the area of the triangle over here. So this is the triangle over here. Okay, so this is the total exposed area. Now you see, if you see the plan, so in the plan it is circular in shape, and your pressure is acting like this. Okay, so we have to reduce the pressure because of the shape. So the shape factor of 0.7 will come into picture into 1.5. So 1.5 is nothing but the wind pressure. So if you remember, we are assuming the wind pressure of 1.5 kilonewton per meter square depending on the city. So if you go for this calculation, you are going to get the horizontal pressure, horizontal force. How much is this horizontal force?
113.4.
113.4 kilo Newton. Okay, so now if you refer this figure, it is acting at this particular level. Okay, so this distance is nothing but the 16 meter. Okay, so this is the 16-meter height. Okay, so it is up to this level, then plus 2.5. So we are at this level, plus 5. So basically we are considering this total height as 10 meter divided by 2. So exactly at the center this particular force is acting. How much is the total distance now here where the force is acting?
So
23.4.
23.4.
23.4 meter. Okay, so it is acting at 23.4 meter. So moment at the base due to this force will be 113.4 into 23.4. How much is this?
2653.56.
Point.
56 kilonewton meter.
Someone please cross check whether it is same or not. ठीक है
Yes,
ये?
sir.
ठीक है. Right. So this is the wind force on the top dome and the wall. So let us go for the second one. So we are right now calculating the forces on the conical dome. Okay, so here you can see the conical dome which is now shown in the purple color. Okay, so the at the center the force will be acting. So this is basically a trapezoidal shape. Okay, so the outer diameter is 12 or the larger diameter is 12 and the smaller diameter is 7.2. So I'm just taking the average of that multiplied by the height. So height is now 2.4 meters. So this is going to give me a exposed area which is in form of a trapezium multiplied by the shape reduction factor, that is zero point 0.7, because in the view, top view, it will be circular in shape like this. Okay, and then intensity of the wind is 1.5. How much is this? Yes, students.
Sir, 24.192.
24.192 kilonewton. Someone please cross check.
Yes, sir.
ठीक है. So now this force is acting over here. Okay, so we have to calculate the height. So basically this is 16 plus half of this 2.5 divided by 2. So this is 16 meters plus half 1.2. How much is this? 17.2. Okay, just calculate the moment at the base, that is 24.192 into 17.2. How much is the moment?
416.10.
Kilonewton meter. Okay, so this is the moment due to the wind force which is acting on the conical dome. Now let us calculate the moment due to the wind pressure which is acting on the ring girder. Okay, so ring girder is over here, so it is acting at a distance of 16 meter, which is there from the which is measured from the bottom to the top of this. And if you remember, the depth of this beam or this girder was 1.2 meter. Okay, so it will be acting at the center, that is half of the 1.2. So the distance will be something like 16 meters minus something like 0.6 meters. Okay, so this is going to give you a very small reduction in the value. So we are not going for this, we are directly going with the 16 meter. Okay, as far as wind pressure is concerned, so if you see from any angle, so the exposed area will look like a rectangle. The depth of that rectangle, so here this depth is basically 1.2 and the width over here, this is nothing but 7.2. So this is the exposed area multiplied by the shape factor, that is 0.7, because the ring girder will be also circular in shape, and the intensity is 1.5. How much is this?
9.072.
5.07.
Sir, 9 point
9 point
072.
9.072
Yes, sir.
kilonewton. Okay, and it is acting at a distance of 16 meter. So this is 9.072 multiplied by 16. How much is this?
145.152.
145.15. Okay, so this is the moment. Okay, now coming to the most important part, they are nothing but the columns. Okay, so now so we have assumed that the number of columns, they are nothing but 8 number of columns. Okay, so in the problem itself, you will find the supports is basically 8 number of columns. Okay, so let me draw a shape. So if you draw a axis which is like this, so we have one column over here, we have one column over here, one column over here, one column over here, then we have columns like this. Okay, so if you assume that the wind is acting in this direction, or maybe even in the other direction, it will remain same. So how many columns will be exposed? This column will be exposed, this column will be exposed, this column will be exposed, and these two columns will be exposed. Okay, because this column will be overlapped with this column, this column will be overlapped with this, and this column will be overlapped with this. So at a time only 5 number of columns they will be exposed. So whatever what I'm going to do is I'm going to calculate the wind pressure on only one column. Okay, and then I'm going to multiply it with 5. Okay, so if you take only one column, so if you see a column which is over here, only this much area is now exposed. Okay, so it's a 16-meter column. Okay, so we have the height of the column as 16 meter, and as far as this width is concerned, this width is nothing but the diameter. So diameter is 650 mm. So I'm going for a simple rectangle of 650 mm. And if you see the column, so column shape is like this, and your wind pressure is acting like this. Okay, so since it is circular in shape, so we have to go for multiplication factor of 0.57, and the intensity is 1.5. And this I'm going to multiply with 5 because at certain point of time only 5 number of columns they will be exposed. So how much is the wind force? Please do the calculations.
54.6.
54.6 kilonewton. Okay, so now the total height of the column is 16 meter. So this horizontal force will be acting exactly at the center, so it is nothing but the 8 meters. Okay, so the moment at the base due to the wind pressure is 54.6 into 8. How much is this?
436.8 kilonewton.
ठीक है, ये समझ में आया? Yes student, is it okay?
Yes, sir.
Yes, sir.
ठीक है. Now the other part which is remaining is the bracing. So you can see there are 3 bracing. One is over here, second is over here, and third is over here. So I'm going to calculate the horizontal force which is acting on the first bracing, and then I'm going to multiply with 3. Okay, so this is going to give me the total horizontal force. But as far as the moment arm are concerned, so for this force the distance will be something like 12 meters. Okay, because the force will be acting at this bracing, and here the distance will be 8 meters, and for here the distance will be 4 meters. Okay, so you can see this 4, 8 and 12. Okay, so as far as the bracings are concerned, the exposed area will be 0.5 because this depth of the bracing we are considering this as 500 mm multiplied by 7.2, that is the width of the bracing itself. This is basically a cross section which is having a flat surface. Okay, so for this purpose we don't have to go for the circular shape factor, that is 0.7. So this time we will go with 1, and then multiplied by intensity is 1.5. Okay, so how much is this total horizontal force?
16.2 kilonewton.
Sorry,
1616.2.
0.2. Okay, so can anybody give me how much is the product of this only, this part?
Sir, 5.4.
5.4. Okay, so you can see 5.4 is acting over here, 5.4 is acting over here, and 5.4 is acting over here. So if you take the moment at the base, So this is 5.4 into 12. So this is the first bracing plus 5.4 into 8. This is the second bracing, and then 5.4 into say 4. This will be the third bracing. Now what will be the moment at the base?
So 129.6.
Kilonewton meter. Is it okay? Someone please cross check. ठीक है. Now see, if you turn back, we have calculated what is the horizontal force and moment due to the wind force at the top dome and wall. So that one part is there. Then second one is the conical dome, third one is the bottom ring girder, fourth one are the column, and the fifth one, they are nothing but the bracing. Okay, so now all we have to do is sum up all the horizontal forces. Okay, so horizontal forces, if I write horizontal forces, all the horizontal forces, so the first horizontal force is 113.4. Okay, so this is something like 113.4. Okay, then we have something like 24.192. Okay, I think then we have 9.072. Okay, then we have 54.6. Okay, and lastly 16.2. Okay, how much is this horizontal force now?
217.46.
Someone please cross check this.
Yes, sir.
Yes, students, can you hear me?
Yes, sir.
कनेक्शन लॉस्ट हो गया था मेरा. लेट मी शेयर द स्क्रीन वन मोर टाइम. कहाँ तक हुआ था?
The horizontal force.
Yes, so horizontal force we have calculated, that is 217.46. Okay, so the moment in the column is nothing but the horizontal force into height of the column divided by 2. So this is 217.46 into 4 divided by 2. How much is this? So this is 4 divided by 2. So exactly double of this. So something like 434 point something
0.93.
kilonewton meter. Okay. Now we have to calculate how much is the MT, that is the total moment due to the wind load. So this also we have calculated earlier. Okay. So for first case, the moment was something like 2653.56. Okay, so let me write down over here 2653.56. Okay, so I am calculating this over here. So this is the first one. Okay, then I think we have 416.1. Okay, then I think we have 145.15. Then 436.8. Okay, and lastly I think 192.6, 129.6, sorry. Yeah, how much is the total?
3781.
Sorry,
3781.821.
someone please cross check this.
Yes, sir,
मुझे
correct.
थोड़ा वैल्यू गड़बड़ लग रही है इसलिए पूछ रहा हूँ. ठीक है कि ये स्टूडेंट, इज इट ओके? ठीक है, फाइन. So this is total moment kilonewton and meter. Okay, 3781.21. So let me write down over here. So this is 3781.21 kilonewton meter. Okay, so now what is happening over here is, if you have a staging which is like this, and we have a container which is over here, and if it is subjected to wind pressure, it is going to bend like this. Okay, and because of this, some additional axial load which will be developed in the columns. Okay, so this additional axial load will be calculated in terms of v2. Okay, so for this purpose you just have to use a simple expression, that is mt equals to m plus v2 divided by d0 by 2 into summation of r square. Okay, so for this purpose, the empty value is already known to us. So this just now we have calculated, that is 3781.21. The value of m. Okay. So the value of m is basically the moment. So you have already calculated the moment as here the value of m is 434.93. So this is the value of m. Okay, so m and mt both are now known to us. The value of v2 we have to calculate. The d0 value is basically 7.2 meters, and summation of r square. Okay, so if you refer the figure which is over here, so from the center you have two dimensions. Okay, one is the distance between the center center of this column with the vertical axis. The same is over here also. So we have two columns which are having the radius from the center as 2.546. Okay, so this you can calculate using simple mathematics, and the other one is from here to here. So we have only one value. So from here to here we have only one column. Okay, so as far as summation of r square are there, you have to go for the both the sides. Okay, so if you go for both the sides, so you have 2.56 which is there for this column, this column, this column, and this column. So your summation of r square will be something like 2.546 iska square. This will be multiplied by 4. Okay, is it clear, student? And then as far as 3.6 is concerned, it is distance over here and distance over here also. Okay, so this is nothing but 3.6 square into 2. So the same value has to be substituted over here, and you have to just solve this for v2 and tell me the value of v2. बताओ.
Sir, 461.01.
Sorry,
461.01.
someone please cross check. थोड़ा वैल्यू मुझे ज़्यादा लग रही है. Yes, someone please cross check. Yes, anybody? Please check one more time because the value is very high. V2. Please, ऋतुज
सर,
करेक्ट है.
हाँ सर, रिकैलकुलेट किया, सेम वैल्यू आ रही है।
I think I am having some different value. It should be around 230. Someone please do the calculation one more time. Your R square, summation of R square is coming out to be 51.848. Okay, divided by 7.2 by 2. Okay, so it is coming out to be something like 14.44. बेटा मेरा आ रहा है 232. I am getting this answer as 232.34. Please check.
Yes, sir. 232.38.
38. चलो 38 ले लेते हैं.
Yes,
ठीक
sir.
है. So this is the answer of V2. So basically this is the additional force which will be acting in the vertical direction in the columns due to the bending effect. Okay, so now the combined effect, that is V1 and V2. So V1 is the vertical load due to the self weight and water load. So this you have already calculated. This is 2549.19. 2549.19 यही था ना. 254519. Yes, and V2 just now you have calculated, so its value is something like 232.38, almost 10% of the load. How much is the actual load now in the column?
2781.57.
This is in kilonewton. Okay, so now this is the combined effect of the gravity loading as well as the loading due to the bending. Now quickly see the moments now. Okay, so we have already calculated the value of m. So m value is something like 434.93. Okay, so this is 434.93. So if you divide this with number of columns as 8, so you are going to get moment in single column. How much is this?
54.36 kilonewton meter.
Kilonewton meter. Okay, So this is the moment in each column and this is the actual force in each column. So if we calculate the eccentricity of the load, so this will be something like moment is 54.36 into 10 raised to power 6. Okay, and the p value is nothing but 2781.57 into 10 raised to power 3. So this you will get eccentricity value in millimeters. How much is this?
19.54 mm.
Sorry.
19.54 mm.
Okay, so 19.54 mm is very very less. Okay, because if you see the diameter of the column we have assumed this as 650 mm. So in respect to that it is very very small. So since it is very very small, the direct stress will be the predominating force in the design, and for this purpose we have to design the column for the actual load only. And the AST minimum you can provide as 0.8% of the cross section area. This is as per as 456 2000 clause number 26.5.3.1 page number 48. So 0.8% of the cross section area. So this is the pi by 4 into 650 square. How much is this?
2654.64.
This is AST main. Okay, so if you provide 25 dia bars, तो कितने बार्स लगेंगे?
Sir, 6.
6.
Yes, sir.
Okay, so we can provide 6 bars of 25 millimeter diameter. Okay, so let us quickly check these stresses. So the direct stress can be simply calculated as the total vertical load divided by the equivalent cross section area. Okay, so the vertical load we have already calculated as 2781.57. So this is 2781.57. Then the area of the concrete is basically pi by 4 into 650 square. The m value, I think m value we have already calculated in the initial, that is 10.98. Okay, so this is 10.98, and AST is nothing but pi by 4 into 25 square into 6. Number of bars are 6. How much is sigma 0 direct stress? Yes, how much is direct stress? चलो जल्दी बताओ. Anyone?
Sir, 7.31.
7.31.
Yes, sir.
Okay, let me note down. 7.31 newtons per mm square. Okay, as far as bending stress is concerned, expression is m by I into y. So m value is, we have already calculated this as 54.36. Okay, so this is 54.36. The y value is nothing but capital D by 2, that is 650 divided by 2. The I value you have to calculate like this. So this is the moment of inertia for the concrete section, and multiplied by, or rather in addition to that, we have the equivalent section for the steel. So here you see this is the distance. Okay, so from here to here there are 6 bars. So you have to take the distance from here to here. Okay, so if you see the clear cover for column, we generally go for 40 mm. Okay, the diameter of the bar is 25. So if you see from here to the center, so this small d can be something like 650 divided by 2, that is the half of that, minus clear cover is 40 minus 25. How much is this d? कितना आ रहा है? कितना आ रहा है बेटा?
260.
Sorry?
260.
260 mm. Okay, so if this is 260 mm, so I'm talking about from here to here, this is 260 mm, and here the angle will be 60 degree. Okay, so let us call this as d dash. Okay, so d will be something like d dash into, you have sine of 60. How much is this?
225.16.
Okay, so your distance square is nothing but 225.16 is ka square, and the area of one bar is nothing but pi by 4 into 25 square. Okay, and this diameter is basically 650 mm. Okay, so you just calculate moment of inertia. Give me the value please. Everything should be in mm. Okay, the small m value is 10.98.
9.172 into 10 to the power 9.
Okay, okay. Just substitute the values over here, 9.172 into 10 to the power 9, and give me the value of bending stress, sigma B.
2.01.
Okay, so now you have these values with you. So sigma 0 actual is 7.31, sigma bending actual is 2.01, whereas sigma 0 permissible is 6, and for bending it is 8.5. How much is this value?
So 1.45.
1.45. ये ज़्यादा आया है?
Yes, sir.
Okay, so what has to be done?
Dimension of
Yes,
column.
so we have assumed this as 500 by 500. So now we have to increase the depth. So you can try for 600 mm, and the entire design has to be repeated. Why? Because if you increase the depth, your wind calculations are going to change. So it is going to add some additional moment. Okay, so uh, you have to oh, sorry, this is I think wrong. Your dimension was 650 mm, so now you have to go for 700 mm. Okay, and then you have to redo the calculations, and your wind force will be slightly increased. Okay, and then accordingly your design will be safe. Okay, so I'm not doing the design one more time. This is just for your demonstration, so please revise the design for 700 mm. Okay, now we will quickly go through the design of bracing. It's a very small design, just a 3 slide design, so we'll complete. So we have already calculated the moment in the column MC. Okay, so if you refer the earlier notes, the moment in the column MC, I think we have calculated moment in each column. कहाँ गया कहाँ गया कहाँ गया? Yeah, here. So this MC value we have calculated as 54.36. Okay, so this is 54.36 kilonewton meter. Okay, so since the bracing is a part of your staging system, some portion of the moment will be transferred to the uh, bracing also. So you can using this expression, so you can calculate the moment in the bracing. So this is 2 times mc divided by cos of 45. Okay, how much is this moment in the bracings?
153.75.
153.75.
150.
3.75.
This is kilonewton meter. Okay, so we are assuming the bracing size of 500 by 500 mm, and we can find out how much is the depth which is required. Okay, so your moment of resistance should be qbd square. So this is 153.75 into 10 to the power 6. Okay, the value of q, I think value of q kitna liya tha? It is 1.527, right? Yeah, this is 1.527 into width. So width I am going to take 500 mm, okay, into d square. This is going to give you a value of d. How much is this d?
448.74.
Sorry.
448.74.
Okay, so this is small d. So if you add let us say if we are using 12 dia bars, so this will be 12 divided by 2 plus clear cover of let us say 20 So this is something like 448.74 plus 6 plus 20. How much is this? So this is going to give me the total depth. कितना आ रहा है? जो भी है, it will be definitely less than 500 mm.
474.74.
Okay, so we have assumed the total depth of 500 mm, so that is sufficient enough to resist the moment, isn't it? So let us quickly check the AST. So if you provide the AST, so your bending moment in the bracing is 153.75. So this is 153.75. Sigma st is 130. J, I think J value कितना आएगा बेटा इसमें?
0.86.
0.86. Okay, and the d value, so d value will be I'm assuming this as this is 500 mm, so minus let us say 20 clear cover and 6, that is the half of the diameter of the bar. So this is going to give me something like 474. बराबर है ये? Okay, how much is the AST? Please give me the values.
1030.32.
Are you sure? Check करो.
153.
कितना आ रहा है?
2901.
2901 millimeter square. Okay, now whether it is less than or greater than AST minimum, that you have to check. Okay, so that can be taken from the IS code. So I'm sure you will find the AST which is required is 2901. It is greater than the actual it is greater than the AST minimum. Okay. So now since your if your structure is like this, okay, so your wind can come like this, which is going to bend the structure in this direction, or your wind can come like this. Because of this, the structure is going may bend like this. Okay, so you don't know the nature of the wind, so that's why we have whatever AST you are going to calculate, you have to provide this AST at the top as well as at the bottom. Okay, this is due to the wind. So for this purpose, okay, how much I think this we can provide 6 bars of 25 diameter. Please check whether it is greater than 2901 or not. कितना आ रहा है?
Yes, sir. 6 bars.
6 bars. Okay, so basically you have to provide 6 bars of 25 dia bars at the top as well as at the bottom. Okay, now as far as shear is concerned, we have a simple expression. MB is nothing, V is nothing but MB divided by length of the bracing divided by 2. So MB is 153.75 into 10 raised to power. Let us not go in newtons and mm. the length of the bracing. So in this figure you can see I have already calculated the length of the bracing, okay, because we know that from here to here it is 3.6 and the angle between over here is 45 degree. So you just do the math and you will get the values, okay. So the length of the beam is nothing but, or length of the bracing is 2.8728. How much is the shear force in the beam? Shear force in the bracing?
So 108.77.
108.77 kilo Newton. Okay, so now if you calculate the shear force, so this is 108.77 into 10 to the power 3. Width of the beam or bracing is 500. The depth is 474. How much is the tau v value?
0.46.
Sorry,
0.46 Newton per mm square.
46
Sir, okay.
newtons per mm square. Okay, now remember we have provided 6 bars of 25 millimeter diameter. Okay, sorry. So correspondingly you calculate the percentage of steel. So width is 500, depth is 474, ast is 6 into pi by 4 into 25 square. How much is the percentage of the steel? Yes, percentage of steel.
1.24.
1.24%. Okay, so if you refer the IS code, you have to calculate the tau c value. So the tau c value value for 1.24%, it is roughly 0.44 newtons per mm square. Okay, so if you see the value, so the tau v value is 0.46, but here the value is 0.44. So for this purpose you have to go for design of shear. Okay, so design of shear is, once again, it is very simple. So the tau v value is basically 0.46, this is 0.44 into b into d. So b value is 0. B value is 0.5 and the depth value is 0.464. How much is the design for shear vd? Yes, anybody please tell me the value of vd.
सर 4 न्यूटन्स बहुत कम आ रही है सर.
हाँ, बहुत कम आएगा, because you see it says the permissible value is 0.44 and actual value is 0.46, है ना. So
Yes.
its value is how much, कितना आ रहा है? 4
4 न्यूटन्स.
4 किलो न्यूटन.
4 न्यूटन्स सर.
No,
नहीं
sir,
ये
in
हमने
kilonewton,
डेसिमल्स में लिया है ना.
sir, kilonewton
4
में
किलो न्यूटन आएगा बेटा.
4.64 into 10 raised to power minus 3
सर 4.64 into 10 raised to power minus 3 आ रही है वैल्यू.
नहीं, ये न्यूटन पर एमएम स्क्वायर में है ना. ये
Yes,
न्यूटन पर एमएम स्क्वायर, ये भी न्यूटन पर एमएम स्क्वायर. तो इसको 500 लेना पड़ेगा, इसको 464 लेना पड़ेगा, फिर वो न्यूटन में आएगा और फिर कन्वर्ट करो, फिर भी 4 न्यूटन ही आ रहा है. 4 किलो न्यूटन होगा बेटा.
yes sir, 4 kilonewton, 4.64.
4.64.
Yes.
Okay, so anyway it's a very small value. So definitely you can provide 2-legged 8 mm dia bars and you can use this expression and this expression to calculate the spacing. Okay, whatever is the minimum that you have to provide. Okay, I hope you can do this. कर लोगे इसको, ठीक है. So we will stop over here, and we will continue in the next class. Only the foundation part is now remaining, that we will be covering in the next week. Okay. Do you have any queries? Yes, students.